The Economist.
Back in Detroit, Henry Ford wondered how he could bring the price of the Model T down to where everybody could buy it.
His solution? The production line. In 1913, the Ford Motor Company revolutionized the way cars were made.
Each man on the line became a specialist. He did one thing, and he did it perfectly, and passed the work along to the next man.
This new, more automated approach massively sped up car production.
Then they put the parts on moving conveyor belts, and the conveyor belts grew longer and more complex.
It worked, and output shot right up.
Mass production and the assembly line drove the price of the Model T down from $850 to $300. Now everybody could have one.
But not everybody was happy.
In the auto industry alone, the big three have invested $7.2 billion in modern automated facilities. And the result has been unemployment.
We had an increase in the total production of cars of 50.5%, with only an increase of 0.5% in the labor force.
Fast forward to today, and talk of automation is back once again.
Can you jump?
That's Nvidia's boss, Jensen Huang, on January 5th. He's explaining to two cute robots on stage with him how they'll be made in the factories of the future.
We have to design the manufacturing lines that assemble all of you. And these manufacturing plants are going to be essentially gigantic robots. Incredible, isn't that right? I know.
Production lines have become increasingly automated, but the old concerns still linger.
The AI inputs is not necessarily connecting with training and education and opportunities that will prevent the workers being totally displaced.
The factory of the future has always been just around the corner. But with AI rapidly expanding, are these concerns finally justified? And are factories about to become unrecognizable? You're listening to Money Talks from The Economist, our weekly podcast on the markets, the economy, and the world of business. In Singapore, I'm Ethan Wu.
In Washington, D.C., I'm Alice Fullwood.
And in today's show, we take a peek inside the factories of the future. Alice, hello.
Hi, Ethan.
So we are the unfortunate crew stuck left behind while all of our colleagues are off having champagne and living it up in Davos. You know, I wasn't picked this year or last year, and that's fine.
Nothing like saying, I wasn't picked, but I'm not mad about it, to make people think that you're completely relaxed with the situation and never even crossed your mind. Yeah, no, I also have stayed on the bench. I guess we should point out, Mike isn't in Davos. He's just at home. But yeah, the top brass at The Economist certainly are all, I guess, talking about Greenland and lots of other exciting news.
I have to say, I'm so glad we're not talking about Greenland and similar topics this week. I think this show, which is on the factories of the future, gets at the point that even as Trumpian intrigue occupies the headlines, things continue to percolate along under the surface. Global capitalism, global supply chains, they never really are at rest. And so it's worth keeping track of how the production processes that shape all of our lives and will shape economies for decades to come are changing. And so this is a topic that our colleague Anjani Trivedi is obsessed with. So I wanted to bring her in here. Anjani, hi.
Hi, Ethan. Hi, Alice.
Is obsessed too strong? You've been running around reporting on this topic for quite some time.
It's a really fascinating topic. We live in a very physical world. Everything is material. Whether it's the microphones we're using or the headphones or the desks we're sitting on, it's all very material. And we have thousands of touch points with factories every day, even though they may seem so remote. And I think what we don't realize is that a lot is changing within these factories.
Okay, so people probably don't think about factories very much, but I guess most people have a rough mental image of what one might look like. People are familiar with the production lines that we heard about at the beginning of the show. When we talk about automating factories, I guess most people are probably thinking of things like car plants with robotic welding and painting arms. So what's driving a change in factories today?
It will come as no surprise that artificial intelligence has a lot to do with it. But that said, the robots have also gotten a lot better. They aren't these big, clunky machines. They are now fine-tuned, smooth, savvy robotic arms and autonomous trolleys running around the factories. And so it really is down to these two advancements which have come together. The industrial software, which is being made better by AI, and the industrial hardware. One of the things that has made it easier is you can use natural language to even tell a robot what to do and to see you through the production process. And I think that's enabled machines to do more complex tasks and faster, more efficiently. And the hope is that these factories can then anticipate what people want made and so on.
Anjani, that's something really important I got from reading your piece, is that there's an important distinction between old robots and the newfangled robots, in that the old robots were rigid and they could often do one thing. And the new robots, they can do more things more of the time and be reprogrammed to kind of handle a variety of situations. You gave a really clear example, I thought, with robots operating on different axes. Can you talk about that?
Sure. Robots could only move across up and down, left and right. And now you see them moving at multiple angles, which means that they are a lot smoother. And their spatial movement means that they can move products or work on certain parts of a machine in a much more precise way. Part of that has happened because the software has gotten better. So software engineers are able to simulate this better. And AI has made that simulation process faster. And you can look at different scenarios of a robot dropping something or a robot moving around in a very confined space. And all of that has translated into robots, therefore, doing more. And to your point, instead of 3, in one factory I went to, they could move in 12 different axes.
Okay, so these robots can be a lot more versatile. They're a lot more precise. Where are all of these changes going? What's the ultimate destination for what factories might look like?
If we step back a bit and we start with the factory itself, right? These factories and the designs of these factories and where the machines go in these factories can all now be simulated in the digital world before it is implemented. They can then figure out how high a ceiling needs to be because a certain machine is going to operate within that and a robot is going to move in so many different directions. So all of that gets simulated and then the factory is built. And that kind of translation from the virtual world into the real world, which is often referred to as digital twins, is something that has sped up the process of making factories, of simulating how productive these factories can be, how older factories can be upgraded to incorporate newer machines. And the idea has always been that the factory of the future gets to a point where it's the dark factory. And these are humanless factories where machines work away 24/7. They can do the same thing over and over again. So repetitive tasks. And there are a few dark factories now across the world. However, the idea now is that with all of this, savvier industrial software, these better machines, and the ability to simulate all of this and make digital twins comes together to make factories more flexible. So a factory could do more customized products. It doesn't have to do mass volumes to make itself an economically viable operation. It could make 10 different things within the same kind of industry based on what the demand is. And therefore, the factory can be more flexible, it can be more efficient. And in theory, people hope that this will mean higher margins on certain things.
And Anjani, you haven't just been studying the factories of the future, you've actually gone to see what they look like on the factory floor.
Yeah, so I was in Germany, and it's obviously famed for its manufacturing sector, its industrial companies, to see how all of this was put to use.
I'm just walking in to one of the biggest industrial fairs in the world, just outside of Nuremberg. We're here to see all the machines that are now being put to work on factory floors across the world, from cables to copper tapes to all the little parts that go inside machinery to the big robotic arms and super fast conveyor belts that are moving goods and products inside factories. Such machinery has filled factory floors for decades, but I'm here to see what the factory of the future will look like.
So I'm Gerhard Feldmann. I spent the last couple of years developing a control system for AGVs, robots on wheels that carry things around.
I'm watching a robot that's about the size of a single-door refrigerator move around, picking up crates and driving them around the exhibit floor.
So what we're seeing here is an automated guided vehicle, and it's designed to move things around in either a production facility or in a storage facility. So in this case, it is moving around magazines filled with printed circuit boards. It could also be plastic parts, it could be toilet rolls, it could be whatever you are producing inside your production facility, moving from point A to B. And the reason people want to use this is to stop having the workers being interrupted. You can imagine if you are someone assembling something and you have to constantly get up to move something around on a little trolley, it's disruptive. So this robot is really just taking over this monotonous, boring part of your daily work.
The size of this trade fair is truly mind-blowing. And in one of the 14 vast halls, I find Rainer Brehm, one of the heads of Siemens' automation business. I asked him, what is driving the need to automate?
Factories always need to deliver productivity, number one. Number two, we have customers which say we have a fluctuation of 20% of our factory workers every year. And the people I get in, they're untrained, they're not skilled.
But it's not just hiring difficulties and the need for productivity that have been a boon for companies like Siemens, which, along with trains and medical imaging equipment like MRI machines, also sells the tools to automate factories. Geopolitical tensions have also been good for business. Tariffs and supply chain snags are putting pressure on global firms to bring their factories closer to home.
So let's assume you want to move back manufacturing to US, where you find the factory workers. So if you could automate more, you can produce more, and you can produce more locally. So there is kind of the supply chain disruption, the topic of tariffs, which are forcing our customers to produce closer to the consumption. But if you move somewhere close to the consumption, suddenly your product costs go up significantly. That means you need to automate more. But you also need to automate more because you don't find labor.
But it isn't just factories in the West that are looking to expand automation.
On the other side, if you look to China, they also automate a lot because they also have an aging society. And the tendency of robots in China is the highest. So there is not only a Western world issue, it's exactly the same like in China where most of manufacturing takes place.
There's around 4.5 million industrial robots across the world. But the move to this kind of automation has been a slow process. So what are the barriers to adoption? And what makes some firms go for automation and others reluctant?
Think about when you automate. You automate if you have a good return of investment. Automation is always great if you have a mass production. This is where automation started. Conveyor belt, Henry Ford, black car, this is perfect. No variance, high piece count, perfect for automation. In the worst case, lot size one individual piece, you don't automate. Because doing this automation costs you more than simply put a human there and do it. So the question now, if you are capable to reduce the money they invest to doing the engineering and building the machine, then the degree of automation goes up because the return of invest is going up. And here especially, generative AI will play a major role because generative AI can now significantly reduce the engineering time, but it also will get more flexibility in manufacturing. And with these two trends, we believe the degree of automation goes up simply because the business case gets better.
So it sounds like the factory of the future will be smarter, more flexible, and will it be smaller? I mean, will we still have these gigafactories and megafactories?
That's a good question. I believe it will become smaller because you want to deliver very close to the consumption. People expect to deliver something at the kind of hour or whatever, maybe 10 minutes after it was ordered. The expectation of the users will be, you need to be a fast delivery, yeah? The same if you see now, in the past you could have planned your production quite steadily. Now having influencers, there's a nice cosmetic where suddenly the demand is tripling, doubling, whatever. So you need to be now flexible to adapt. If you are the first one hitting the market need, you make the business. And I think this will be the winner of the future, who can adapt flexible close to the consumption.
We were talking about flexibility. How flexible are we talking? Are we talking the same car factory can make 15 different cars? Or can the same car factory make cars and motorcycles? I mean, what are we talking about?
Maybe that would be a good thing. Like cars and motorcycle in one factory, I would see that. I don't know whether there would be, in the future, a contract manufacturer which could manufacture cosmetics and car in one factory. I don't see that. Because you have different machines, different process, different regulations. Don't underestimate as well regulations, yeah? If you produce food, it's different than you produce cars.
Thank you so much.
Thank you.
Replace people and boring tasks with smarter machines, build factories that can make a broader range of products, and bring all of that closer to the consumer faster. That's how you build the factory of the future. So is that what's happening in reality? Almost no one knows more about factory automation than Ben Armstrong, a research scientist at MIT's Industrial Performance Center.
I think we're still quite early in the cycle of adopting physical AI tools onto factory floors and seeing a sizable impact from these tools on productivity and performance of these manufacturers. If you look, for example, at the R&D facilities and academic labs like the ones at MIT, these are places where the new technologies of manufacturing have been around for decades before they actually reach the factory floor. And today, you see robotic technologies in academic facilities and in robotics companies that are 5 generations ahead of what you see in the even advanced robot user manufacturer.
So what do today's automated factories look like? To see for myself, I went to visit one of Siemens' own factories in Erlangen, just outside Nuremberg, where they make drives. Now, drives look a lot like a desktop computer, and they go into basically any bit of machinery that moves. They control how fast the motor powering that machinery spins. In simple terms, they are essentially the brain of a machine, and making them looks as complicated as you might imagine.
Hi, I'm Anjani.
Hi, I'm Stephan Schlauss. I'm responsible for the manufacturing network of motion control, and I will show you around. So we're going now in the factory. One thing is we have to put on special clothes to go in the factory. At the same time, please take care. There are AGVs, autonomous guided vehicles, running around. They are very safe, but they are sneaky, and therefore just don't make a sudden move because they try to sneak behind you.
So now we're walking through the factory, which is remarkably sterile, white lit, and extremely automated. There are several technicians, but there are also many more machines that they are controlling. Watch out for this AGV here.
We disturb now the
We've disturbed
his direction very shortly. He will find this new direction.
And we're now standing by a line of robotic arms that are picking up a cover which goes on to a drive. The covers are like the back cover on a TV remote. How did this machine work differently a few years ago?
There was not any of this machine because you have a low volume production. So you didn't have a machine who could do that kind of steps before in a good cost-value ratio.
So a robot could probably do some soldering and testing before, but now because volumes are up and the cost-to-value ratio works.
Not the volume, but how we implement smart robotics. What this robot can do is he can pick parts out of a box which haven't been sorted.
Now, picking parts out of a box may not sound like a complex task, but it's actually very difficult for a robot to do. Imagine a box of jumbled plastic coverings that need to be fitted to a drive in a certain way. For a human, no problem. You instinctively know how to pick up the part and turn it to snap it into place. But a robot needs to learn that skill. And that's where AI comes in. By simulating over and over every which way a plastic cover could fall into a box and then letting the robot virtually figure out how to pick it up, you can train this line of mechanical arms how to do the task for real.
Now with the new technologies, artificial intelligence, we train the robot to identify parts in the real world. In order to do so, we create the data you need to train such algorithm in the virtual world, which means we shake the box virtually 10, 20,000 times, and afterwards the algorithm is able to identify exactly how the part is lying in the box and how to grab it. And if you would do that one in manual, you would need years to get all the data, 20,000 times shaking a box and measuring how the parts are lying in. And now suddenly the same algorithm can identify with a very cheap camera. This camera is only costing €200 to pick and identify the parts and to assemble them in the correct direction as a human being is able to do. Suddenly, you can do things which from an economic perspective you wouldn't be able to do before, because you need a very expensive 3D camera costing €50,000, something like that, instead of €200.
In other words, AI means factories can do more with less. In the past, even just grabbing a plastic cover from a box of plastic covers required an expensive 3D camera. €50,000 is far more than someone on minimum wage in Germany would earn in a year. So it didn't make sense for factories to replace workers with machines. But lower the cost of that robot, and suddenly the economics of automation start to make a lot more sense. But it's not just the physical manufacturing process that's being automated. It's also the day-to-day running of the factory, from first steps to packaging up finished products.
So now we walk in our outbound center, and what we're doing here is we're directly sending the products to our customers.
So we've just walked into the logistics center and the packing line, where robots are moving around cartons, parts are being put into boxes off of conveyor belts. The boxes are of different shapes and sizes. The parts that are being packed into those boxes are also of different shapes and sizes. It's largely automated to the extent the machines can tell what they're packing and the exact boxes they need to go into, unlike, say, a package that you might receive from an e-commerce provider where one tiny part is inside a massive box.
What you can see is here how we prepare all the products. Customers not want to have one single product, but he wants to have a bunch of different products for his specific needs. So besides the drives, he wants to have motors, he wants to have cables, he wants to have connectors.
How did this happen 5 years ago?
Manually. Somebody had to pack it somewhere. Then he saw how big is the pile, and then he put it in the right box. Or sometimes he judged that might be the right box and he put it in the box, but then finding out, oh, box was too big.
It used to be guesswork.
Each customer is ordering different. That's the problem. If everybody would order the same, then it's easy.
We've just left Siemens' Erlangen facility. There was a lot of autonomous machines, from the robots that were moving around the materials to the logistics area. But it did strike me that the amount of effort and training and data that it takes to perfect the task that a human needs solved is just huge.
If I'm honest, after leaving the factory, I was left feeling that it was the robotic equivalent of using a sledgehammer to crack a nut. Millions of dollars worth of robotics were being used to do something relatively mundane that a low-wage worker was doing a few years ago. So back in the center of Nuremberg, I went to meet the person in charge of all of this to delve into the economics of automation.
It is freezing. It is supposed to be negative 10 degrees Celsius here tonight. I'm here to meet Cedrik Neike, who runs Siemens' digital industries business and is on the board. We're meeting in a sushi restaurant. I'm worried it's going to be a bit loud, but let's see how it goes. Cedrik, thank you so much for doing this.
Thank you so much for having me.
Cedrik, one of the biggest barriers to adoption has been the cost for companies to really invest in this machinery and think about it on a long-term basis, because ultimately these are big upfront investments. How do you kind of make the case when it comes to return on investment, when it comes to payback periods, when it comes to capital allocation?
So I used to work in Silicon Valley for 16 years, right? And we used to have a saying which was eat your own dog food. I'm half French, I say drink your own champagne. So I will talk about our own factories. I mean, Siemens has more than 100 factories, and the way we're doing our decisions is in the following way. There's a base investment you need to do to be able to build the data backbone of the factory, and that's an investment you have to do. But once you do it, we get around 7% productivity out of our factory every year in electronics and 9% of our mechanical. And the reason is that the return on investment is within 2 years, maximum 3 years. So what I'm trying to say is, if you have a brownfield factory, so an existing factory which you need to constantly rebuild, or greenfield, new factories, build it with a way that you don't know what you're going to produce in a couple of years. You need flexibility, resilience, and you need the capability to bring sort of productivity out of it. So the way I'm always telling all my customers, come and see my own factories, come and talk to my CFO, don't talk to my engineers, and have him tell you exactly on what investments you need to do when to be competitive over a longer period of time.
We've heard about dark factories and lights out factories for a very long time, but that implies that there's nobody in there. There's these humanless operations that are just churning out goods after goods. And then at the same time, we're talking about innovation and we're talking about upgrades. There's a bit of tension there. So how do we really think about the factory of the future then, of this dark factory? And at what point do you need human intervention for innovation?
So I personally believe in the human-centric factory, to be very honest. And the factories which you can visit at Siemens are 40, 50 years old, and they're the same amount of people which are there after 50 years. We just have massively increased the amount of products, the output, and the quality. And the people have been becoming much more highly educated to be able to do this. There will be a place for dark factories because there might be certain elements where you don't want humans there. One of the factories which haven't really come about, but which will come, is vertical farming. And in vertical farming, you don't need humans because humans bring sort of non-quality to the food production. It's actually dangerous in that way. You will have microchip factories, which probably will become quite dark because these are super clean rooms, etc. But there will always be humans. The question is, will they be in the factory, outside the factories, or with the factory? And these factories will be way more flexible and way more efficient than they have been in the past with the adoption of those new technologies.
Cedrik, thank you so much.
Thank you so much for having me.
So what does all of this look like in 5, 10 years from now? I asked the factories expert, Ben Armstrong from MIT.
You know, if we were talking in the late 1800s, the factory of the future would be pretty clearly something that's very standardized and focused on mass production. If we were in the 1950s and 60s, we wouldn't know it yet, but the factory of the future would be lean and much more flexible. And today, I think our best guess is that the factory of the future is much more intelligent in two ways. One is that it relies a lot more on skilled labor, skilled engineering and production labor, less than the commodified, replaceable labor of the past. And then second, there's a lot more intelligence in terms of the data that's being collected to optimize what can be manufactured and when. And I think that intelligence allows for much more efficient use of resources. So factories can be far less resource intensive with less waste. They can also be faster to produce new things and much more flexible. So they can go from producing one good with certain materials that looks a certain way to another with a flick of a switch.
And that means that factories, which were once teeming with blue-collar workers, will eventually all be full of technicians, engineers, and data wonks. And those people, those factory workers, will be needed to keep innovating and building the factory of the future, which, after all, isn't an end state, but an aspiration.
Anjani, thanks so much for all that. It was a really great report. I just wanted to ask you for your reflection on some of the questions you raised toward the end. I mean, how much do you think we're heading toward a future of dark factories? Do you think there's going to be a substantial role for, let's say, less technologically sophisticated workers in the factories 20 years hence or 50 years hence?
Look, when you think about the kind of leading edge of factories, These will be very automated. You'll see robots whizzing around and going up and charging themselves and so on. But you will always need someone very skilled to operate the next level of the machine. So even if software runs ahead and artificial intelligence gets to kind of the limits that we talk about today, integrating that into the hardware will require human intervention. One of the plants we went to, they were creating an industrial co-pilot that basically knew the manuals in and out and knew every tool on these giant machines, knew what could go wrong, had data on all of this. And so you could, just like with ChatGPT, a technician who isn't fully well-versed in that specific machine could come in and say, how can I fix this? And it tells you from the instruction manual in plain spoken English what to do. Ultimately, hardware, unlike software, does not change overnight. That process will become faster because of AI, but ultimately the limiting factor will be the hardware, which also needs to evolve.
I guess everyone is familiar with the story of how electricity changed factories, right? So you had these manual garment factories or whatever, and then electricity came along and they electrified, they started using machines, but it took decades for people to rework the shape of the factory floor around electricity to get the sort of real productivity gains. And as a consumer, I think it can be hard to understand how in modern factories, the idea of shifting the factory floor around to suit a change in production, it can be hard to understand just how disruptive that is. I remember I used to drive past the Mini Cooper factory in Oxford on my way to school. And it was the kind of place you would people would perennially go on school trips and things. And I remember them explaining how long they had to shut the factory down to switch which side of the car was the driving side for European versus British vehicles. And it was like half a day. And they had to shift all of the equipment over from one side of the line to the other side of the line. And it was this huge inefficiency in their manufacturing process. And what you have described, these robots that are versatile and can be reconfigured around different production needs, you can almost imagine some sort of choreographed dance among all the robotic machines now as they shift into building, not even just that small change in the driver's side of the car, but making all kinds of different products. And the thing that seems really powerful is that if there's an inefficiency in the factory floor, it's not going to take you decades to rework how it's shaped. You probably could even experiment, change something small one day and see whether it is any faster and better at making things. Yeah, it sounds very exciting. It left me very hopeful for how productive factories can be in the future.
It's quite topical, isn't it? I was in Seoul last week taking some meetings, which you may hear about on a future episode of Money Talks, but not today. And the buzzword I was hearing almost every meeting I took was physical AI. And one of the reasons for that was the week prior to me being in Seoul was the Consumer Electronics Show in Las Vegas, where all the major Korean tech and industrial companies were represented. And Boston Dynamics, which is a subsidiary of Hyundai, had unveiled this humanoid robot called Atlas, which won the Best Robot Award, which I didn't know they had at the CES show. But, this is sort of like an Elon Musk style, humanoid dancing robot, but one that's engineered to kind of do industrial processes to fit in on the factory floor. And it was clear that Boston Dynamics had been thinking about the economics of robotics that you flagged, Anjani. One of the headlines that came out of the show was that Boston Dynamics is looking to price the Atlas humanoid manufacturing robot at the equivalent of 2 years' pay for a U.S. factory worker, which is around $320,000 US. I assume that includes benefits and other stuff like that. So there's the technology side, which will continue to proceed apace. Then there's the economic side, and you get into questions of labor capital substitutability, right? So what is this is a classic economics question. What is the optimal mix of labor and capital? It may not be 100% capital. It may be that getting from 70% of your factory running on robots to 90% is actually prohibitively expensive, but that getting from 25% to 70% makes total economic sense. It's exciting that we're in the phase of individual companies having the technology available to start making that labor capital substitution decision. It's going to make factories more efficient, more productive. I guess the hope is that factories in the West get on this before the Chinese just do 3 laps around whatever we're able to pull off in Germany, right?
One of the things that's happening in China is that they are starting to make cheaper robots. And one of the problems in the West has been that adoption has been very slow. And that's primarily because once they put in machines, those machines have a long life and they look at it from like a 10 to 15 year perspective. They get retrofitted. And so then that extends their life. And so the investment in a new robot therefore takes time. Whereas in China, they've realized this. And so they're making cheaper, smaller robots and they're being adopted at a faster pace and so on. And I think as people adopt more robots, there'll be a better sense of what works. And to your point, the balance of labor and capital and the various kind of factors that go into ultimately raising productivity.
Well, with that, it's time to turn to the least labor-intensive part of the show, our stats of the week. Anjani, why don't we give Alice a second and let you go first?
Well, my stat of the week is global foreign direct investment. That was $1.6 trillion last year, which was up about 14%. I think this was quite interesting, one, because in a world where talk of economic fracturing is rife, money is still sloshing around. Notably, of course, FDI in developed economies was up and in developing economies was down. So it kind of a sense check on where money flows are in the world.
We continue to need more factories and more stuff, it turns out.
My stat of the week this week is 20%. And that is the probability that Polymarket is assigning to the likelihood that Trump will acquire Greenland before 2027. There are a whole slew of these like Greenland probability markets on Polymarket, I guess because there are so many paths that this insane story could take. Will it be invaded? Will it be the end of NATO? All these kinds of things. But 20% is the chance that the United States will officially announce that Greenland will come under US sovereignty by December 31st, 2026. Bleak, that's pretty high.
I was going to say 20%, notably the same probability the New York Times election needle gave Donald Trump in 2016 against Hillary Clinton. So, hey, the world is full of crazy 1 in 5 surprises.
Great. Good luck, people of Greenland, I guess.
Well, I have a slightly more cheerful stat of the week, and that is, I cheated a little bit here, but it's 1.5 trillion, but that is in won. That's about $1 billion US. And it is what HSBC expects the K-pop band BTS will generate in sales in the year 2026. 1.5 trillion won or $1 billion. Now, that's a lot of money. As you might have heard, BTS is making a big comeback this year. It's going to be absolutely nuclear. There's like 3 shows in Singapore. I'm not going to be able to get anywhere for like a week on the train. But what was interesting about this number is the breakdown of where that revenue is coming from. The bulk of it is in concert sales. Talk about labor intensive. This is the way the music industry is going. No one buys records, streaming doesn't pay, but concerts really do sell. So I hope the 7 beautiful boys at BTS are well rested, well hydrated, because they're going to have a lot of labor in the year ahead.
You said they're coming back. Did they ever recede? I feel like K-pop has been just perennially at a fever pitch.
They had to do the conscription.
They had to do military service? Oh my God. Being in BTS doesn't get you off military service. Korea doesn't mess around, does it?
Hey, the North is still there. It's not going away.
Well, don't mess with Korea, I guess.
All right. Well, with that, I think all that's left to do is to thank Anjani Trivedi for joining us.
Thanks for having me.
And thank you for listening to Money Talks. If you know someone who might enjoy this podcast who is not an Economist subscriber, there is a way to share it with them. Find the episode on the Economist app, click the share button, then select Give us a gift.
You can always write to us at podcasts@economist.com.
Today's show was produced by Eleanor Sly and Tom Wolfenden.
Our sound engineer is Timo Sila.
Dan Asher is our editor. And the executive producer is Hannah Mourinho.
I'm Ethan Wu.
I'm Alice Fulwood.
And this is The Economist.